Hey, hi, in this video, I'm going to show you how to enable Azure Kubernetes cluster monitoring, that is AKS cluster monitoring using Prometheus and Grafana. As you see in this PPT depicts my demo. So here what I'm going to show you is, I'm going to show you that how to spin up the AKS cluster with using Terraform, where I'm going to store the state of the AKS cluster in the Terraform cloud. And we're going to spin up a AKS cluster in the Azure subscription. I have an Azure subscription. Once the cluster is spinned up, we're gonna run the few commands, that is few kubectl commands or few helm commands on the AKS cluster, which will configure the Prometheus and Grafana parts on this AKS cluster, which will help us to monitor the or have the observability on the Azure Kubernetes cluster. And finally, I'm going to help you with how to access this Grafana dashboard, and where we can see the the performance metrics, the monitoring, the data about the complete AKS cluster, right? So in total, this is purely DevOps based setup, and end to end it is automated. So that's the specialty of this video. So stay tight. I'm going to walk you through the from scratch to end, right? So and finally, I'm going to I'm going to help you to understand, to feel that how the AKS cluster monitoring can be enabled on Azure Kubernetes service, right? So the in simple term, the flow of this video is very simple, right? So here on GitHub repository, where we use it as a version control tool, we're going to keep our Terraform file, which will actually spin up the AKS cluster. Or in general, in Terraform, we will specify like how does your Azure AKS cluster should look like, right? And also on the same repository, we also define our workflow files, our GitHub action workflow files, which will spin up the AKS cluster. And also once the AKS cluster is spinned up, it will actually configure the Prometheus and Grafana configurations on the AKS cluster, which will default scrape the metrics logs from the AKS cluster and try to visualize in a Grafana dashboard, something like this. Okay, so here I'm not only using the Terraform cloud for storing this one, but also we are also configuring this AKS cluster with using the Prometheus and Grafana. So here I'm going to use open source Prometheus and Grafana, the images, where we will use helm commands to actually to configure these utilities on the AKS cluster, right? So the flow is like this: you have a developer working on this infrastructure as a code. It could be Terraform or it could be workflow files, right? And we will have a pointing to the Terraform cloud, where I have a workspace where the state of the AKS cluster will be kept in, right? So once the AKS cluster is spinned up, we will have a task defined in the workflow, which will actually run the helm command, which actually configures the AKS cluster to have an observability or to monitor the the AKS cluster, right? All right. So with that note, what I do is I'm going to take you to the my GitHub repository. So this is my GitHub repository, that is Azure AKS. So if I take you to the my GitHub repository, so this is how it looks. So this is my GitHub repository. If you go here, so I have a repository called Azure Labs, Azure AKS Labs. So this is the repository where I have kept everything. I did also showed you the demo on like how to spin up the AKS cluster and how to host an example application on the AKS in the previous video. You can watch it. This video is purely focusing on how to enable the observability on the AKS cluster. Okay. So by considering that, I'm going to go very fast here. So basically, so in this AKS folder, these files you see: variable.tf file, sh.tf file, provider.tf file, output.tf file, right? And main.tf file. And finally, we have a AKS apps. So this is an example app which I'm not using in this video, in this demo. I'm just focusing on these files, that is the other .tf file, which actually spins up an dedicated AKS cluster with the right configurations. And then we directly jump to the workflow, that is Azure AKS monitoring. So the magic is happening in this workflow, in the sense this is the workflow which is actually automating the two things. One, it actually creates an AKS cluster. Once the AKS cluster is created or successfully, it's gonna take the the kube config of that particular AKS cluster and runs the some helm command dynamically, and make sure that the required Prometheus and Grafana parts are configured or applications are deployed on the AKS cluster, right? So how did I do that? So that is something I'm going to walk you right away. So here, so this is the my name of my workflow, that is Azure AKS monitoring with using Prometheus and Grafana. And this workflow will be invoked with using workflow dispatch, which means that this workflow will be invoked by manually. And in this one, we are actually using the some permissions: ID token write and content equal to read. So likewise, I have a definition. I have only single job, and that job has a multiple tasks, right? So I'm going to walk you through down the line now what is those tasks and all. So here, this is my job name. Whatever you give the name here, it will become your job name. And then it has a runs on, which is actually the default GitHub action machine. Then we have a default runs configuration, that is shell and the working directory specification. So I'm making my working directory equal to AKS. Why? Because this is with the place where I have kept .tf file, which is actually a Terraform file, which is used to spin up the AKS cluster. And then in the steps is nothing but a list of tasks that you're going to do in this job. So here, first one, we are checking it out with using this action checkout at the rate version 3.1.0. And then finally, this is the place where I'm actually using the SPN OIDC, that is Open ID Connect based authentication, to get access on the Azure subscription with using Open ID Connect. And that is so basically that Open ID Connect belongs to an Azure SPN, and that SPN has a client ID like this, and tenant ID like this, and subscription ID like this. So these are all the secrets which I have kept as a secret on my repository, right? And those secrets are being reused here, and these credentials enables us to log in into Azure subscription. Okay, and this login is a purely secure credential-less. All right. And then we go to the next one. So next one is the Terraform, the tasks, multiple tasks mean for running the Terraform, the jobs basically, right? The first one, in the first part of the demo that is walking through this, right? So I was mentioning Terraform Cloud. So what I did is I have a Terraform subscription. So this is my Terraform subscription. If I go to the back to the my workspace, so this one. So this is the organization that I have, that is cloudquicklabs. In that one, I have created a workspace called Azure AKS Labs. Right. So on the Azure AKS Labs, I have configured the required authentication variables. That is nothing but the SPN based authentication variables. That is ARM client ID, ARM secret ID, subscription ID, tenant ID. So these are nothing but you create an SPN, you create a secret of that SPN, and that secret value has to be kept here. Client ID has to be kept here. Subscription ID has to be kept here, and all these are secrets, right? And the key name has to be exactly like this. Okay, so do not create key value apart from this. In the sense, even capsule, even the letter, it should be in a caps and with the underscore as well. Okay, so that is very important point. And category should be environment, right? So once you configure these, right, then you are actually enabling Terraform Cloud to take an access on the subscription and compile the Terraform definition which you have written in those Terraform file, and spin up the AKS cluster in the Azure. And then finally, the state of your infrastructure will be kept in this workspace. The workspace which I created is Azure AKS Labs. So this is the configurations which we maintain. And here, and one more thing is, we need to create a TFC token. So basically, you can go to the settings, and here you will have basically you go to the user settings, and then in the user settings, if you go to the tokens, so here you can create a token. So I have created a token which will expire on the 20th. So if you want to create a new token, you can create it from here. So it will have an access on your organizations. Okay, and that token is again kept as a secret, and that is been referenced here, right? So follow this format. Anyways, I'm going to share this file in the GitHub repository, and the GitHub repository's links is shared in this video's description. You can find it from there and try to use it as it is. Then let's go to the next task. Okay, so this is all about how did I set up the Terraform connection, that is Terraform Cloud connections. Then let me go to the next one, that is Terraform init. So basically, whenever we do a Terraform command run, the first thing we need to do is Terraform init. So basically, Terraform init is something like that. It actually initializes the Terraform connections, which actually basically downloads the required providers, blah blah and all. Right, all the modules will be downloaded in general. Basically, just like if I can tell you in a layman term, when you before you use the modules of the Python, you need to do a pip install, right? For example, say pip install panda, and once that pip install has been done, then only you can use the panda module, right? So likewise, Terraform init is meant to do those prerequisite downloads, and then Terraform will try to then Terraform will try to run the rest command, that is Terraform validate, Terraform plan, and Terraform apply. So here I'm running a Terraform validate just to check the syntax of the these files, right? So in the main file, I have a resource type. If I go down, so this is the like the basically the main part of the demo, which is actually a definition of creating the Azure Kubernetes cluster, right? And all these Terraform files are being compiled against validating the syntaxes and proper, basically the checks the proper syntax of the Terraform. And then we have a Terraform plan task as well, which will actually runs the Terraform plan against this folder, which will compile all these Terraform file and try to create a draft plan. If there is something error in the plan stage itself, we're gonna have an exit task, which is actually is like a evaluating task, in the sense it just checks whether the Terraform plan has gone green or not. If it is not green, it will exit from here itself, right? That is something like proactively I'm just stopping the running Terraform apply. And then we have a main task called Terraform apply, which actually runs the AKS cluster and spin up the AKS cluster for us. And then finally we have a Terraform output, which actually prints the output which I have defined in this output file. So if you want to have more, if you want to understand more deeper understandings of this file, please watch. If you want to understand these files information in more details, please do watch my previous video. All right, and this is the this is like a heart of this video. Basically, this is the place you need to understand correctly that how I'm making it automatic, right? So basically, so this video is showing you everything CI/CD pipeline, everything configuration in the CI/CD pipeline. There is no manual intervention here, right? So remember that so in that case, how I'm enabling and monitoring capability on your AKS cluster post the AKS cluster is spinned up, right? That is AKS monitoring enabler, and then this is where actually magic is happening. First one, I'm doing AZ AKS get credentials. So I'm running AG CLI command in the context of that particular run, that is particular GitHub run. So how it is getting the credentials? Because if you see here at the top, we are actually doing a AGCL login. In the sense, this workflow session will already have required credentials. In the sense, that session already has the context of Azure subscription. With that context, we are running the AGCLI called AKS get credentials. This is my cluster name. This is my resource group name. So this you can make it dynamic. For now, I have hard coded it for second time. And then comes the Helm commands. In the sense, we are running the Helm commands to to install the required Prometheus and Grafana the utilities on the AKS cluster. Right. First one is we actually have to add the Helm repositories to the runtime. Right. So basically that's the reason the first command is Helm repo add Prometheus community. In the sense, so this is like Prometheus managed Helm chart, and that Helm chart will be added as a trusted repository in the runtime. Okay, during the whenever the workflow runs, it will run Helm repo add Prometheus community, which will actually it will add a Prometheus community Helm charts into the local run, and then it runs the Helm repo update. In the sense, it just updates the Helm repository. And then we have a single command, right? So you might be aware of the Helm utility in the Kubernetes world or container world, that so basically this is like kind of a small unit which actually makes big thing, in the sense like small utility, a small commandlet which actually simplifies so many things. Okay, for example, say if you want to, in the sense, basically Helm command is nothing but a wrapper of multiple kubectl commands, you can call it like that, right? So multiple kubectl commands, in the sense kubectl apply, kubectl delete, kubectl blah blah blah, right? So all those kubectl commands, if you wrap it, and that will become a Helm in a very layman term, you can consider like that, right? So for example, to install a Prometheus and Grafana, you might need to run kubectl apply Prometheus, kubectl apply Grafana 2 times. Instead of that, you can do as a Helm chart, which actually runs a group of kubectl commands in a one go, right? And that is what happening here. That is right. So here you see Helm install Prometheus community, and this is the the stack, and we are actually deploying this. Basically, whenever you do Helm install, it actually does a kubectl deployment actually, right? So that deployment should happen in a namespace called monitoring, and we are actually putting a basically parameter called create namespace. If this namespace is not there, create it like that. Okay, in that namespace you need to deploy this stack, that is Prometheus stack, right? And in that one we are actually deploying the Prometheus community Helm chart definitions. And finally I'm doing remove forcibly I'm removing the kube file. Basically, when I'm running this command, which actually updates my kube config file, which I want to remove once my task is done, to make it very secure, right? Alright, so this is what I have defined the workflow in GitHub Actions, so which will help me to create a cluster, AKS cluster, and also configure the required Grafana and Prometheus. Now what I do is I'm going to run this command, run this workflow as a demo. So what I do is I have made unnecessary changes which does not make sense, but still it is good enough for me to show you the run. All right, so this is our Azure Azure AKS labs, which is my repository name. I'll go to the actions. In the actions I have the workflow. So this is Azure AKS monitoring with Prometheus Grafana, right? So this is the my workflow name. I'm gonna run it against my main branch. I have only one branch, but though. So I will just click on this one. So you see that the workflow has started now. So this is purely live demo, in the sense whatever happening, you should be believing whatever I've showed in this video. And this is like a fresh configurations being shown you from the scratch. Okay, so while it is running, what we do is we just have a watch, and I'm going to walk you through as a commentaries. Okay, so basically here, I'm just, you see that currently we are doing AZCL login, in the sense it is using the OIDC connect from the SPN and try to log in into our subscription. Okay, you see that it is using the OIDC authentication, federated token has been retrieved, and then it has logged in successful. Then we have a Terraform setup is been done dynamically. Then we are using the Terraform init as well. So Terraform init is now flowing off. Then we have a Terraform validate is running now. So Terraform validate is been done. We have the Terraform plan is running now. So you see the Terraform plan is been compiled against the AKS folder. So it basically, when it runs a Terraform plan, it just compiles the Terraform file present in this one and tries to create a draft. So while it is running here, we can go to the workspace basically. So we can go to the workspace and we can see that the runs are happening now. So if I go here, you see there is a run is happening. We can click and see the live here as well. Here you go. So whatever it is shown here in the GitHub Actions. So basically these logs are mirrored in the GitHub Actions. Okay, in general term. So right now we are running apply, because if I go to the Terraform plan, it says there is no change because we have not modified any Terraform code. So that's the reason it is like a no change, right? So currently, so when you run a Terraform apply, basically in the backend, it also runs two things. One, it also runs a Terraform plan and also runs a Terraform apply as well. So currently it is actually evaluating the changes by running the Terraform plan, and looks like it has done the job. You see that the Terraform plan is done, output is done. So in the output, I'm just printing all the required formats, so you can go through the output definitions of this repository as well. Now you see that so basically it has failed. Okay, so let me show you why it is failed. So here you go. So basically so I have already run that command again, so that's the reason it is throwing the error. If you see here, according that kubeconfig Prometheus is added in the successfully upgraded the Prometheus. Update is complete, happy ending. So installation is failed, cannot reuse the name, still it is in use. In the sense, basically, so this command I have already run. I'm gonna show you the successful run for the first time, because when I'm running the second time, it is throwing the error. So no worries. So basically, it is already been successful. So if I go to this workflow and go to the last run, that is AKS monitoring, right? So you see that the cubes kube Prometheus stack has been installed. Okay, so when I'm running it for second time, it is throwing the error. But what you can do is you can do a kind of a trick which will actually check that the deployment is exist or not. Then only you can do a Helm install, or else you can do a Helm update basically, right? That is what it is asking, right? So why it is throwing? Because I have already run this command. So you can do something like since it is a bash command here, you can do you can do the if else condition and try to run the Helm install or Helm update according to the parameters. Okay, so that magic you can do it. All right, so for now, the aim was to just to show you that the enabling the AKS monitoring with using Prometheus and AKS, right? So we have this configuration has been done. Okay, so basically with this configuration, our cluster should be up and running fine. This is my so currently I will take you to my Azure subscription. This is my Azure subscription. Currently I'm in a resource group, and here go I have the these many resource groups. So one is the master resource group, which is actually has my cluster. So this is my cluster which we have just now created. So here if I go to the namespaces, so we should have a namespace called monitoring, and in that monitoring we should have our workloads running fine. Okay, so let me show you that as well. So here you go. So we have a monitoring workspace, and if you go to the monitoring workspace, so we should have the the basic definitions as well. So currently it is loading, you see. So let me go to the workloads. So if I go to the workloads, so here you can see the the deployments, pods, blah blah, and so let's go to the pods, and let's select the the monitoring basically. So these are the the pods are running in the monitoring namespace. It includes Grafana, Kubernetes, Prometheus, state metrics, blah blah, right? So we have just run Helm install, and that Helm install command has run hell lot of pods, in the sense hell lot of applications basically, right? And these are all pods are monitoring, and all are in a healthy state. We can also see this status from the kubectl command, which I'm going to show you right away. and then the replica set. You can also see the the stateful set, daemon set. Okay, basically you can explore these configurations from your side as well. So now let's go to the service ingress. So currently I have not explicitly configured any service ingress, but still we have a service because because we have installed the Prometheus and Grafana. So all these parts has a service in front of that, and those are all being replicated here. Let's go to the ingress. So currently I have not created an ingress. So for now I'm just using the port forward method to access the Grafana dashboard, which I'm going to show you right away, right? So that is how you can explore the Kubernetes cluster that we created. Then one other thing is the another one is the managed resource group, that is managed container RG. So this is like a Azure managed RG, which has these list of resources. It has a public IP address, virtual machine network security group. It has a route table, a network, and then we have a managed identity for the cluster, right? So likewise, we have a network watcher resource group is also been created. All right. Okay, so with that, basically this is how the infrastructure is being spinned up, and this is how the configuration is being done, right? Now time has come to access the Prometheus dashboard or Grafana dashboard. So I will show you how to access the Grafana dashboard like that. So this is our cluster, right? So what did I do is I have used AZCLI to log into my account from the Windows command prompt, or you can use any command utility. Go there, you can use any command terminals and go there and try to access the your cluster with using AZCLI. First one, I'm logging into my AWS, in my Azure subscription with using AZ login -- use device code, right? So once that is been done, I will go to this site and then I enter this code, and then eventually it is allowed me to log in into my account. So this is my account or basically subscription, and my subscription name is Azure cloudquicklabs, right? And then once that is been done, I have set with the context. The next command which I run is something which I showed you in the workflow, that is AKS get credentials. This is the resource group name, this is the cluster name, right? So when I type this command, basically what it does is it will interact with the AKS cluster, gets us the kubeconfig. So kubeconfig file is a file which actually contains the configurations through which you can interact with the AKS API server, basically, right? And then if I go down the next command just to check the status of the pods, that is Prometheus pod, I did run kubectl namespace monitoring. This is the monitoring get all pods belongs to the release like Prometheus, right? And it has listed me all these pods and their status is running. Now the time has come to access our Grafana dashboard. So to access the Grafana dashboard, we need to run command called kubectl port forward namespace is this namespace and that namespace should happen to a service called Prometheus Grafana, right? And we are accessing it over port number 8080 and over the HTTP, right? So I did access that. Now let me do this again for your information. So I have articulated all those commands in a readme.md file. You can try to use these this help file from your side, right? So if I have walked you through very quickly, so you can also do from here like this. Anyways, I'm gonna give you like a hints like this one. This is RG, right? And then here is the basically you can put it like here is a cluster name, right? So this is the cluster name, so you can put it like this. So this is a cluster name, and similarly so basically so this is what basically this file is shared in GitHub repository. GitHub repository link is been given in this video's description. You can find it from there. All right, so now let's go to our last command of the demo, that is to do a port forwarding. So I am running this command, that is kubectl port forward on the namespace, on the service, this service, and over the port number 8080. All right, so it is trying to connect now. So let's see if the forwarding gets initiated. Once the forwarding gets initiated, you can go ahead and access the this one, that is HTTPS local or something like this. Okay, so just let me copy here. So I'm gonna go to this one. So this one, HTTPS. So currently port forwarding has not yet been initiated. So currently it is still still hang on mode basically. So maybe I need to go on a pause and come back because I need to run these commands again, right? To get you to show you that visualization. Okay, stay hang on. I will be back. So basically yeah, here you go. So I'm not going to hang on here now. Luckily, so port forwarding has initiated now. So basically we can go ahead and try to refresh the local host. This is the local host IP address. Then on the port number 8080, and then we have login. So basically it is, you see that it is has started to load the Grafana one. And if I go to the this one, that is the handling the connections for on the port to 8080, which means that it is able to access it basically. Yeah. So or yeah, so here you go. So loading the Grafana, and it has successfully loaded, and it has came into a login page where that's where we can put in the user ID and password. The default user ID and password of the Prometheus Grafana is admin, and the password is promo operator. So we do login this now with using these credentials. All right. So I'm gonna go to the promo operator. All right. So this is my password. So what I'm doing is I'm trying to log in to Grafana with using these credentials. Okay. All right. Looks like we have successfully accessed the our dashboard. So basically we were here now, in the sense this AKS cluster is up and running fine. We have a Prometheus installed. We have a Grafana installed. Now I'm accessing this Grafana endpoint or UI by using the port forwarding method. So let's go to the home. Click on the home. I will just go to the dashboards. In the dashboard, so there is a default general folder, which actually by default Grafana provides you a ready-made dashboard which we can reuse. We don't need to build it. Okay, so I'm very lazy to build it. All right, because it provides the required the dashboards for us. Okay, so let's go and explore the cluster. Let's check how does our cluster dashboard is looking now. Here you go. Right, so this is very nice visualization of what is happening on my cluster. So it has a CPU utilization 8%, it has a request blah blah and all. Right, so there are so many things are happening here. So you can go back to the dashboard again. I will say the discard, and try to, you can also try to do the basically yeah, so you can also do a pod namespace level checks as well. So I'm just taking, these are all no data. So there are few things which are not being collected by default, so you need to re-enable it again. Right, so likewise you might go to the nodes, let's say nodes. So hopefully that at least this has a data. Here you go. Right, so we have a data for each pods level. You see, this is the pod level data. You can visualize the pod level data, blah blah and all. And you also have the memory data. So everything is being displayed here very nicely. And this is becomes a place where you can absorb the AKS cluster. So basically having a observability, having a monitoring on AKS cluster makes sure that that your workloads are being hosted properly, and they are doing the required job, in the sense your application is running as expected. So that's the reason it is very important for you to monitor the Azure AKS cluster with using Prometheus and Grafana. All right, so with that note, I have shown you the things need to be shown in this video. Finally, I can request please do subscribe my channel. That would really encourage me a lot. So with that note, thank you, thanks a lot, and see you in the next video.